In this video, we'll see an example of how to use the graphical user interface for the vertical matchmaking service. This service provides the optimal hardware platform and hyperparameters to run a given algorithm with respect to a given target. We can also impose some constraints. For example, we could want to minimize execution time for an algorithm while keeping memory usage under a certain threshold. Let's see an example for the FWT algorithm. Let's say we want to minimize execution time while also imposing the memory usage to be less or equal than 30. We can click on the Optimize button to launch the optimization process and we'll get a solution. The solution includes the optimal hardware platform, the optimal values for the hyperparameters, and also estimated values for the targets, both the optimization target and targets that were constrained. The optimization process could result in other two outcomes. We could either get no solution, for example, if we impose an unfeasible constraint, for example, if you want memory usage to be less or equal than -2, or we get a detailed error message in the case something went wrong in the optimization request. For example, if we insert a string instead of a number as a constraint value, we'll get constraint value must be numerical. There are two classes of algorithms. We have seen an input-independent algorithm. In this class we have just hyperparameters and targets, but we also have another class called input-dependent. For these algorithms we also have input variables that the optimization process can leverage. We can fix values for some of the input variables, all of them or none of them. To fix them, we have to provide an input file that must be structured as a JSON file like this, where we indicate which variables we want to fix and the value we want to assign. To see which input variables are available for a given input-dependent algorithm, we have to resort to the REST API. We have to go to /algorithms, /name of the algorithm we are interested in, for example, anticipate. And we see that into the input-dependent section, we'll get the description for all the input variables.